Let's start today's topic. Cyclic redundancy check. Our today's topic is CRC, cyclic redundancy check. It is an error detection technique of data communication. Normally, CRC code applied on data link layer of OSI model in data communication and networking. We can create cyclic codes to correct errors. Some cyclic codes are used for only detection, and some of cyclic codes are used for correction also. CRC, cyclic redundancy check, is a normally only a detection code that can be detect errors from discarded some errors, arised errors. Errors normally occurred on channels using noises, hazards, etc. So, CRC identify these errors and uh, applying on received data and then decide the data is acceptable or not acceptable. In this section, we simply discuss a subset of cyclic codes called the cyclic redundancy check (CRC), which is used in networks such as LANs and MANs, yeah, local area networks and wide area networks. We can normally use in all type of transmissions because of all transmissions are performed using OSI model, and the data link layer is the responsible for error detection and corrections. We can see the main approach using this diagram. So uh, it includes a sender side and a receiver side. There, the two main components, encoder uh, as well as decoder. Encoder at the sender side and decoder is used at the receiver side. Normally, encoder encodes some our data with some other codes, and decoder decode these codes uh, to get separately data and added by encoder's bit. Now that we take an overview of this simple approach, uh, we can see that at the center side, initially we get a data word that is of 4 bits. Not always, only as example, we can take 4 bits A0, A1, A2, A3. That is our data word. Now the data word is goes to generator, and generator generates some zeros and append with our data word, and mm, generator use mainly uh, divisor dividing approach. At generator, we divide our data words and encoders generated bits um, by any divisor. The divisor always fixed digits, that is depend on the size of data words. So we can see that how can varies that normally if we the data word has k bits. Normally we have in this example we have 4 bits. Secondly, the code word has n bits, that we have 4 bits, for example, 7 bit, for example. So the value of k of 4 and the value of n is 7, and our data word is a 4 byte, and our code word that we want to send to other node after encoder encoding, that is of 7 bits. The size of the data word is augmented by adding n minus k, that is 3. Here n is 7, k is 4, so the 3 zeros to right side of the word, that is these zeros. These 3 zeros are appended by generator and then applied on division techniques. Division technique on that proper generated data word plus encoder bits. Finally, the generate the n bits result is fed into the generator. The generator uses a divisor of size n minus k plus 1, that is 4 bits. The generator divides the augmented data word by the divisor. And finally, the quotient of the division is discarded. The remainder R2, R1, R0 is appended to the data word to create the code word. That is a simple approach. After generating some extra bits, we have to divide by a divisor. The divisor includes number of bits, that is always n minus k plus 1. According to our example, the number of bits in divisor is 4, and and divi- after division, the quotient is discarded because we don't have any use of quotient. Normally, we include the remainder bits that is added, that is append with our data word that creates code word. Uh, नॉर्मली जो कोड में अपने पास जो डेटा वर्ड होता है उसके अंदर जो भी इनकोडर के बाद हम डिवाइड करते हैं, जो भी रिमाइंडर हमारे पास बचता है, उस रिमाइंडर को हम कोड वर्ड डेटा वर्ड के साथ जब ऐड कर देते हैं तो हमें एक कोड वर्ड मिलता है, और दैट कोड वर्ड विल सेंड टू फर्दर our communication node. Uh, there the approach. Then the receiver receive a 7-bit code, that is B3, B2, B1, B0, Q2, Q1, Q0. That is the mix-up of uh, data word and remainder that getting on encoder. Now we have to check that and the data has errors or the data is error free. The approach is used is reverse of generator. Here we use checker, that is check uh, our code word and separate the syndrome bits. Syndrome bits are those bits those node belongs to data word. Syndrome bits, and then the syndrome bits feed to decision logic, and the decision logic mainly check whether the syndrome bits are 000, then the data will be accepted because there is no error in the data transmission. Otherwise, if the syndrome bits are non-zero, any one bit of syndrome is 1, then the data is discarded because of the data is infected by errors. So we can check in the decoder what is the process of decoder. The decode receives the code word, possibly corrupted